Alright, in this video it's time to get the load functionality up and running inside of our node saving example. And of course in the last video we had established the ability to save nodes out to a file. Now we need to do the opposite of that operation. We need to load in this new nodes file and read all of the information out of that file in order to reconstruct a node graph. Now to begin, we're going to scroll down just a little bit here inside of Node.io, and we are going to put together a new method. This is going to be a public static method with a void return type, and the method name is going to be LoadNodes. Once again, we will take in a string parameter to indicate the file we wish to load. So we'll take in a string file name. Then we can block in our method body, and we're ready to begin working on the LoadNodes method. Now the very first thing we need to do inside of LoadNodes is establish the ability to open and read from a text file. And to do this, we will be using a stream reader. We will also, once again, employ a using statement to make sure that our file handle gets cleaned up. So we will drop in our using. Then the variable we are interested in is going to be a stream reader. We will call this variable reader, and we will turn around and instantiate it as a new stream reader. We need to pass in the file name, so we'll simply drop in the file name parameter. Then we're ready to close up our parenthesis for using and drop in a statement block for the using statement itself. Now inside of this using statement, we're now ready to begin reading lines out of this file, but if you remember from the last video, we had established a dictionary that would allow us to reference node ID numbers from actual node references. Now we're about to run into a scenario where we need to do the opposite, where when reading from the file, we are simply presented with the node ID numbers, but we need a way of referencing those back to the nodes that they actually belong to. So right off the bat, we're going to define a dictionary, and we're going to use this dictionary to look up node references based on integer node ID values. So the dictionary is actually going to be defined opposite of the one earlier, where the key is of type int and the value is going to be of type node. We're going to call this dictionary node ref map for node reference map. And we are going to turn around and immediately instantiate the dictionary. Alright, now that we have the dictionary ready for use, we now need to loop through all of the lines inside of our nodes file. In order to do this, we're going to establish a while loop that will continue reading as long as we have not yet reached the end of the file. So we can say while not reader dot, actually let me grab the operator here, so while not reader dot end of stream. So while we have not yet reached the end of the stream, we will continue reading. Now in order to read a line from the stream, of course we could simply say reader.readLine. So invoking the read line will let us read out a line of text, returning a string, and advancing forward in the stream itself. Now in addition to simply reading the line, we know that the lines in our nodes file have been formatted in comma-separated fields. In order to gain access to those fields, we're actually going to take the line that we read back and perform a split operation on it. So we'll perform a split, and we'll split using the character as a single comma. Now looking at the split method, we can see that that returns a string array. So in order to store this information, we are going to create a string array called fields. So that means fields will be equal to reader.readline.split on comma. And that way we'll simply immediately store everything as fields rather than having an intermediate step where we look at the line by itself. Alright, now that we have all of the fields on each line, we can now inspect these fields and see if they happen to be a node line or a connection line. So we'll construct an if statement that says if fields sub 0 is equal to the string n, then we know that we have a node line. And again, this is simply because we've broken up our text file to where the first field is actually the kind of line. Subsequent fields will then contain the data for that line. Now in addition to looking out for node lines, we also need to watch out for connection lines. So we will establish an else if statement that checks to see if fields sub 0 is instead, grab 0, is instead equal to the string C. If this is the case, then we're looking at a connection line. So jumping back up to our node lines, we now need to read the information out of all the fields held within the file itself. So once again, just for a visual reference, I'm going to bring this file back up in our nodes text file. So basically we'll have nodes sub 0 will contain the string n, nodes sub 1, if I can grab the connection line over here. There we go. So again, field sub 0 will be n, field sub 1 will be 1, fields sub 2 will be 290, and fields sub 3 will be 339. Now all of these are of course going to be strings, so we'll need to do some conversions to read these numbers back in. So out here in our code, let's establish variables for each of the things that these fields represent. The first will be an integer called node ID. And node ID will need to be set to fields sub 1, but we will also need to convert that. So we will run convert.toInt32. Then we can pass in the string value of fields sub 1. That takes care of the first field, and the operation is very much the same for the remaining fields, so I'm actually going to take this variable line and paste it 2 additional times. We can move on to the second variable, and we will change the type of this to be a float, and we will call the variable simply x, because field 2 references the x position of the node. So fields sub 2 will get converted to, in this case we need to convert not to an integer, but to a float. As far as the CLR type is concerned, this is actually going to be a single, so we need to run a conversion to single. Now, since this line actually did change quite a bit, I'm going to copy the line, paste it over our third line, so we've already established that the variable is a float, and we're using to single. But in this case, the variable name is going to be y, to represent the y position of a node. And that's going to need to look at the third field. Alright, with all of this information gathered, we now have everything we need to reconstruct a node, minus the connection information. So let's actually create a new node object. So node will be equal to new node. Now we need to restore the position for that node. So we will say node.position is equal to new vector 2. Then we can pass in the values x and y that we had just loaded from our data file. Now that takes care of the node's creation and positioning, but we need to do one last thing before we can handle connections themselves. We need to make sure that we build a reference map using our dictionary every time we load in a new node value. So what we'll do is we'll take our node ref map, and we'll say node ref map sub for the current node ID. And again, node ID is the variable we had just loaded out. So we'll say ref map sub node ID is equal to the new node. And once again, this makes it very easy to look up this actual node reference based on an ID number that we may find. Alright, with all this in place, now we have our nodes getting reloaded and the ref map being rebuilt. At this point, we should actually be able to test the functionality as it has progressed this far, though we will, of course, be missing connections between nodes. Now, in order to test it, we need to be able to invoke it. So let's jump over to the scene editor and scroll down in our keyboard input, locating the very end where we had been looking out for the Control-S combination. Let's actually copy that entire else if statement. Then we can simply change the key that we're looking for from S to O, so we can use the combination Control-O to open up our nodes file. Then inside of node IO, we'll simply change the method to look at load nodes rather than save nodes, looking at the same nodes text file. So with this in place, let's go ahead and run. So bringing up our game, of course, we still have a blank scene. Now if I hit Control-O, we can see that 3 nodes get created and positioned as they had been originally positioned. Of course, they are missing their connections in between the different nodes. We see no form of connections because we have not yet reconstructed them. So we'll close out the game, we'll switch back over to node IO, and now we are ready to address our connections. In order to read the connections in, we need to look through their fields and resolve the information that they're currently holding. The connection fields are simply holding the links between one node ID to another node ID. So we'll make our first integer value simply called node ID, and we'll set this to be equal to the converted value. So convert.toInt32. Then we will pass in the current field, which is going to be fields sub 1, and we'll store that over in node ID. Then I'll take and duplicate this line, because once we've grabbed a node, basically these connections lines are saying that, okay, from this node we have a neighbor node, and the neighbor's ID is held in the field. So we're going to name this variable neighbor ID. So neighbor ID, convert.toInt32, this time from fields 2. So this way we can reconstruct the connection from a node to its neighbor by ID. Now, in order to establish the actual connection, we need to do so using real node references. Now, fortunately, we've already run, or rather loaded, all of our node lines, which means we have actually built the nodes themselves and constructed the map so that we can find those nodes. So now we're ready to take and find the references themselves. We're going to do this by making two node variables. The first variable will simply be called node, and it will be equal to node ref map sub node ID. So once again, we're just using this dictionary to look up an actual node based on its ID number. Now we'll do the same thing for the neighboring node. We'll make a node variable called neighbor, and we'll set it to be equal to node ref map sub neighbor ID. Now with these two node references, we have real actual nodes, and that means that we can connect them. So all we'll do is we will take the node reference and we will invoke the connect2 method, passing in the neighbor. And this needs to be the actual neighbor reference. So we'll finish off our parentheses there. And now it's also important to note that with each of these cases, each of these C lines, we are only establishing a single connection. So we only use a single connect2 rather than using something like bidirectional connect. Because in this case, the fact that there are two connections, or can be two connections between two nodes, that is already represented in the file itself. Earlier we had looked at and found where node 2 was connected to node 1, and there was a second connection from 1 back to 2. So both of those will get reconstructed by individual connect2 calls. So with this in place, we should be ready to go with our code. Now I do want to point out one thing. So far we've found that this code is indeed working for resolving these textual fields back to numeric values. But at this point, we do not have error checking in place on these conversions. The conversion routines actually throw exceptions if they were unable to convert the string back to a number. Now in our case, we're just trying to show the loading mechanism working. We're not going to address specific error handling for the various kinds of errors that can occur. I just wanted to point this out because, again, the focus is just to get the data loaded back in and see how we would do that. Now, if you did want to continue from this point and add exception handling in case you found invalid values, you would simply have to decide at what level you were going to handle exceptions. What I mean by that is you could handle exceptions at a very high level outside of the entire while statement, or rather the entire while loop, and then you would have a scenario where the moment an error was encountered, you could properly handle it, prevent the crash of the application, but you would have an incomplete load of the node network. You can also handle errors in a more fine-grained manner by putting a try except around the individual conversion lines, or each line that's getting read in. That means that for each exception, you would only lose a single line of information. But again, you'd have to decide which would be more detrimental to the loading operation itself: an incomplete node network that stops, or the possibility of invalid or missing connections on a node-by-node basis. Or a third option would be to simply note the fact that there was an error and completely wipe the network and just tell the user that the load had flat out failed. But again, since there are different ways that you could implement error checking based on the result that you desire, we're not going to worry about error checking in this video. We're just going to get all of our data working properly. Now with this in place, we should be ready to read in connections. So let's run the game once again, hit Control-O, and we see that we get 3 nodes constructed with connections between these nodes. Now if we move them around, we can see that they are indeed connected. So we have now established the ability to save out and reload node information. One last test I want to run is I'm going to go back to the scene editor, and I'm actually going to resave out the entire node graph, the earlier example graph, just to show a larger set of data being saved and loaded. So if we run with our grid in place, we could hit Control-S, close the application entirely, jump out. I'm going to close the notepad that we currently have open and relaunch it. We can see that once again we have the scenario where we have many nodes being saved, and then after those nodes we have lots and lots of connections. So you can see that from our first node we have 3 actual connections extending out from it. And then subsequent nodes have more and more because center-based nodes will actually have more nodes surrounding them and therefore more connections. So we can see that we do in fact have a lot of node information. Now if we run the game, we can see that, well, we're still reconstructing this graph procedurally. Let me close back out and comment out our construction. So we can see if we load to a blank scene, we still have that data file with all the node information. So at this point we can hit Control-O, and our entire grid is brought in and reassembled. And of course we can move individual nodes and see that all of their connections have indeed been restored. Now there is one final thing I want to point out about the loading code. As earlier we had separated our saving code into 2 separate loops to ensure that the node ID map gets fully built before we attempt to use our connections. On the loading side, we are simply relying on the fact that connections get written after all of our nodes. So we don't need to actually do a check or do a separate loop through our file, as long as that file was constructed properly. Now at this point we're assuming that we're only reading files that we ourselves in this app have written, so we're just going to take it that it is implied that connections will have to come after nodes to make sure that on the loading side of things we get all of our nodes and therefore a full node ref map before we address any connections. So just wanted to point that out, that the order is in fact important, and you do need to have all of the nodes in place in the text file before you have any connection lines. Now with this code in place, we have fully established the ability to reload node networks, so that's going to wrap up this video.